Bismillahirrahmanirrahim. Assalamu alaikum. I am Fakhr Lodi and this is the 21st lecture of Formal Methods for Software Engineering. In the previous lectures, we have been discussing formal techniques based upon horse triple, जिसमें हमने pre and post conditions को use करते हुए हमने मुख्तलिफ उसकी formulations देखी, and we also looked at some semi-informal techniques and tools. Those semi-informal techniques and tools included object constraint language and design by contract, and based upon design by contract, we looked at a tool by the name of J contractor and so on and so forth. तो हमने देखा कि किस तरीके से horse logic की base use करते हुए, horse triple को use करते हुए, how can we define or specify programs and functions, and we can perform different techniques, and how can we formally talk about those programs and then use those techniques for formal verification, construction, as well as runtime debugging and development, which are some semi-formal techniques. Today we are going to start a new topic and a new technique. This specification technique is known as algebraic specifications. Algebraic specifications are used for specifying abstract data types. So what happens is that in our systems, when we have large systems, we define systems and we define their interfaces, their APIs. And the idea really is that, we define some systems and subsystems and modules within those subsystems and so on and so forth. And we precisely define the API through which we can use these subsystems. The algebraic specifications, they can be used to specify the interface of those subsystems so that other subsystems, they can use those subsystems. So this is a precise definition of the interfaces. And algebraic objects that we have, they are very relevant in today's context when we are talking about object-oriented paradigm. Object-oriented paradigm, the classes that we have, they are abstract entities, and those abstract entities can be treated as abstract data types. These abstract data types can be specified with the help of algebraic specifications. So we shall see how can we do that. There are many different notations used in the literature, and there are many different tools and languages developed for algebraic specifications. So today we shall start looking at some generic kind of structure of algebraic specifications. And then, we will be looking at some specific tools that we have, and then I'll try to demonstrate one of those tools and show you how these tools can be used with algebraic specifications and how useful these tools and these techniques are. So first of all, let us look at the structure of an algebraic specification, the generic structure of an algebraic specification. The structure of an algebraic specification can be divided into 5 parts. The first 2 parts, I'm not going to go into the detail right now, but I will be talking about those things a little later in more detail. The first 2 parts, they are called the introduction. In the introduction, we have the name of the specification. So this is the kind of the name of the document that we are producing, and it may have certain generic parameters. Then we have what is called the sort. Sort is kind of a type. So we are defining the type. So, in algebraic specification, it is called the sort. So we define the name, and it may import other specification. It may use other specification. So we will talk about what does that mean, what is meant by importing specifications. So in the introduction part, we have two components. First is the name of the specification, and the second starts with the name of the type that we are trying to specify and other specifications that it is using. Now then there are three more components. The third component is an informal description of the sort and its operations. Although this is a formal specification, but we do give informal description just to, as an annotation, just to clarify it. So we will have a sort and we will give informal description of the sort and the operations that the sort provides, the operations supported by this sort. Then we have what is known as the signature, operation signature. This is basically what we do is we set out the names and the types of the parameters to the operations that we are defining over this sort for which we are specifying or giving this algebraic specification. And finally, we have axioms which we will use to define the operations that are supported by this particular sort. Now here we have a couple of things that you need to remember and understand. The first one is the specification name. So it is just a generic name. It's kind of name of the document or whatever. So name of the specification that we have. And it may also specify some generic parameters that it may use. The second part is the name of the sort. The sort is the same as a type. So what we are doing here is, maybe, if you look at it from a different angle, this sort is kind of a class. So what we say, when we say sort name this, it is roughly equivalent to saying class and giving the class name. So sort is kind of the class. So it is that reserved word, if you will. So you give the name of the sort or name of the type that you are defining, and also specify the other specifications that are going to be used inside this specification. And what does that mean? We will talk about that. Then we informally define or specify the behavior of or the functions that are supported by this particular sort that we are defining. These functions that we have, they are of, they could be any, just like the functions that we have in a class. So we give an informal description of those functions. So what these functions are, their parameters and what they are supposed to do. Very imprecise, informal specification, informal description of those functions. So the third part is really an informal part. It is not a formal part, but it helps us in understanding the formal specification. The real specification starts in the fourth and the fifth part. The first two parts, they were just the introduction, just specifying the name of the sort that we have. But the third part was informal part. The fourth and fifth, this is where the real formal algebraic specification is. The fourth part is called the signature. In the signature, we formally specify the functions supported by this sort. And what we do is, basically, we are giving the signature, okay, name of the functions, the parameters that this function takes, the types of the parameters, and the return value of this function. So it is kind of a header of a function. In our C++, if we have the class, we have the class specification and we have the class definition. In the class specification, we have the signature. We say this function takes these many parameters of this type, and this is the return value. So this is, or the type of the return value. In this particular case, the signature is very, very similar to that, and it is equivalent to the header component of our class. The fifth part is where the semantics of these operations are given. These semantics are given in terms of axioms. So what we do is we write axioms. The kind of axioms that we saw, it is slightly different, but the basic formulation or the concept is very, very similar. So what we will be doing is we will be writing those axioms, and with the help of those axioms, we will specify the behavior of these operations. In the previous case, where we used the horse triple, the behavior of a function was specified with the help of pre and post condition. Here, the mechanism is different. These axioms are going to be different, and what happens is that we will be specifying the behavior of the functions in terms of other functions. So this is the basic structure and basic formulation of an algebraic specification. Now, how do we write algebraic specifications, and what are the things that we need to do? Let us look at this particular example. In this example, the example we have to start with is a very simple old example of an array. So what is an array? Array is a data structure in which you can store values, and they can be accessed by their index and so on and so forth. So this is what we are going to specify. Array is an abstract data type. You can have any type of elements stored in that array. You specify the type of that array, and then that will be the type of the elements that you can store. Here we are not going to do that. We are going to give a generic type, that is the element. So what we have, let us look at this particular example. So in the specification of an array, we have, this is the name of the specification. So we give it a name. We say this is an array, all capital, and the parameters that it is going to take is element. No particular type is used here. We are simply saying, it is going to have some elements. And another very interesting thing that we are saying here is that there is a special kind of element called undefined, and it is of type element. What is the use of this undefined? We will look at shortly. So this is the first part of our specification. The second part is now we are actually defining the sort name. So the type that we are defining, or the abstract data type that we are defining here, is array. So sort, that is the abstract data type for an array, and it imports a specification of an integer. So we are assuming that this integer has already been defined somehow, and it is going to use this integer. Intuitively, we are going to use this integer just like the kind of integers that we have. The third part, it's not shown here. This would have the informal specification of the operations that are supported by this array. So here we are saying the array is supporting these 5 operations. We have create, we have assign, we have first, we have last, we have eval. So once again, these are generic names, and you can map these to your normal array operations. This create is a method which is used to create an array. So it takes 2 integers and it creates an array. So this is the parameter, input parameter to this method or function create, and this is the output. So these 2 parameters are the starting index. The first one is going to be the starting index, and the last one is going to the last index in the array. For example, I can say create an array with indices from 1 to 10. So I will have 1 here and 10 here, and it will create an array for the type of element that I give here. The second operation here is assign. In the assign operation, I have this array. So this is the input. I give an integer which is the index, and I give an element to be stored. So this element will be stored in this array at this index given by this integer. So what I get back is an array which has been modified. So this was the input array. I get an array which is an updated version of the input array. Then I have the first. This function, when I give it this parameter array, it gives me an integer which is the first index in the array. And last, very similar to first, it would give me the last index in the array. And this function eval, it takes 2 parameters, array and an integer, and what it does is it gives me the element stored at this index in this array. So it gives me the element that has been stored there. Now we have seen this basic specification signature of the sort array. This is slightly different from the way we use the arrays, but you can easily map it onto your normal arrays that we have. Couple of things to note here. Remember that if we write programs in C, C++, Java, the starting index is going to be 0. So in those languages, we only give one parameter when we create an array. For example, if I say int a10, so it creates an array where I can store 10 elements and the indices will go from 0 to 9. But in this particular specification that we have, there are many languages like Ada, Pascal, and so on and so forth. where you can specify the starting index and the end index. So you can start, you can say the first index is -10 and the last index is 10. So here you have indices from -10 to 10, and the total array size is going to be 21 in this particular case. So we are specifying this particular case. We are specifying, the starting index as well as the last index in the array. If we had a language like C or Java, we could have only one parameter, and it would work accordingly. Then we have two methods that give us the first index and the last index of array. So if I wanted to find out what was the first index, if in our C or Java the first index is always 0, but in other languages, if I specify a different index, if I wanted to find out, I have this function that tells me what is the first index. So somehow that information is maintained with the array. And similarly, what is the last index? It should give me the last index. So these three operations, they are very simple operations. The other two operations, in the first operation, what we do is we store a value at a particular index. So what we say, with this array, for example, in C, when I write A bracket within square brackets 2 is equal to 5, so here I'm giving the array A. So A is my input array. The index where I want to store the value is 2, and the value that I want to store is 5. So this is basically that assign operation. So you can easily map this onto your normal arrays. And finally, we had, we have this eval operation, which gives us the value stored at a particular index. So if I say, x, for example, is equal to A2, or simply write A2 in an expression, this A2 means, A is the input array, and 2 is the index on which I want to, from which I want to get the value. So this A2 will give me the value stored at index 2 in this particular array A. So once again, this is the same thing, only written in a different manner, but essentially the same thing. Now we have to write the axioms. We have to write the specification for this sort array. How do we write the specification? So there are a couple of concepts that we need to know before we can start writing the specifications. So let us look at once again these functions. There are 5 methods or functions supported by this sort array or abstract data type array. 2 of these, the first 2 in this particular case, they are returning an array. In the first case, this method create gives us a new array. It creates a new array, and assign takes this array and updates this array and stores this element at this index given by this parameter. So these 2 operations, they actually modify or create an array. They change the state of the array. The other 3 methods, they take this array as parameter, and they give you certain output back. In this case, the method first gives you the first index, the method last gives you the last index, and eval gives you the value stored at this index. These three methods, first, last, and eval, they do not change the state of the array. So the first two methods, they change the state of the array. In the first case, it is kind of a constructor. It is creating the array, and here you are changing the state of the array by putting a new value at some index, some place in your array. The methods that change the state of a sort, they are called constructors. So these two, they are constructors methods. Although the constructor, we have a different concept in object-oriented paradigm, but here constructor means any method which changes the state of the object on which it is operating. And the methods that do not change the state of the array, they are called inspectors. So these three methods, first, last, and eval, in this particular case, they are inspectors. And the first two methods, create and assign, they are constructors. So before we start writing the axioms, we have to identify the constructors and the inspectors. So what are our constructors and what are our inspectors? Once again, please note that the constructor, the concept here is different from our normal object-oriented paradigm. मसलन C++ में हम कंस्ट्रक्टर उस मेथड को कहते हैं जहां पर उस टाइप का या उस क्लास का ऑब्जेक्ट क्रिएट हो रहा हो, तो वो मेथड जो कोई ऑब्जेक्ट क्रिएट करता है, दैट इज कंस्ट्रक्टर, एंड वी मे हैव मोर देन वन कंस्ट्रक्टर्स. बट इन algebraic specifications, the constructors are those methods where the state of the object may change. So सिर्फ जहां पर ऑब्जेक्ट क्रिएट हो रहा है सिर्फ वो कंस्ट्रक्टर नहीं है in this terminology, but all those methods which change the state of an object. So ऑब्जेक्ट चाहे एक बार क्रिएट हो गया है, उसके बाद आप उसकी स्टेट चेंज कर रहे हैं, even then that method is called a constructor. And the other methods, they are called inspectors. All those methods that do not change the state, they just look at some value, they may do some calculation, whatever, but they do not change the state. It is kind of a query that they are performing. And this kind of a method is called an inspector. So we identify the constructors and we identify the inspectors. Now, when we start writing the axioms, we specify what we are going to get. How do we get something? We get something through an inspector. The job of an inspector is to give you an output, give you some value back. So we define the inspectors in terms of constructors. So this is the general rule of thumb. The general rule of thumb is, once again, that we write axioms for inspectors in terms of constructors. So जितने हमारे inspectors हैं, in this particular case we had three inspectors, first, last, and eval. And for each constructor we will use the constructors for each of the inspectors. So we will use these constructors. The two constructors that we had, they were create and assign. So for each inspector we have two constructors, so that means for each inspector we are going to write two rules or two axioms. So the total number of axioms that we are going to write in this particular case is going to be 6. So once again, in general, this is what we need to do. That is, we take the inspector and we write the axioms in terms of the constructors that we have. So what does that mean? I'll show you with the help of this example, and I'll solve this example. I'll write the axioms so that you understand what is meant by all that. So here we have these 3 inspectors. The first, last, and eval. And we have 2 inspectors. We have create and we have assign. So what we are going to do is we are going to write axioms for each one of these in terms of these 2 constructors. So let us first write the simplest of the axioms. We say we want to find the first when we have created. So we apply this constructor. When we apply this constructor, remember the input to the first is array, and it gives you an integer. So this was our signature for first. So how can we get an array? We can get an array through this create or through this assign. Create creates the array, and assigns basically modifies the array. So here we write this create. This create takes 2 parameters. So let us call these 2 parameters as f and l, the first and the last 2 indices. So this method, when you do that, so these are 2 integers that you get. So these are the input parameters, and you get an array out of this thing. So when we look at this thing, this method create, what does it give you? This method creates an array with first this f as the first index and l as the last index. So if, for example, f is 2 and l is 10, so the first index would be 2 and the last index would be 10. Now the question is, when I put this query onto this array that I have just created with these values as indices, what should I get back? The answer is very simple. When I apply this method first onto this array that has been created by this create fl, the answer that I get back is f. That is, I should get this value that has been input here in this particular case. So here you saw very easily what we have done is, what we need to do is k as a parameter, we say how can we get an array? We can get an array through these 2 constructors. So the first constructor was create. Create gives you an array. So array is a parameter to the method first. And we apply this first function onto the array that has been passed as the parameter. we should get the value which has been passed to that method create, and that is what we get. So it's a very, very simple operation. ज़रा थोड़ा सा इसको आपको सोचना पड़ेगा. ये थोड़ा सा अनकन्वेंशनल मेथड है, बट अगर आप थोड़ी सी इस पर तवज्जो दें तो इट इज़ अ स्ट्रेट फॉरवर्ड काइंड ऑफ थिंग. कोई इसमें मुश्किल बात नहीं है. जो दूसरे मेथड्स हैं, दूसरे एक्सियम्स जो हैं, वो इससे ज़रा थोड़े से ज़्यादा कॉम्प्लिकेटेड होंगे, बट दिस इज द सिंपलेस्ट ऑफ द एक्सियम्स. We can write the axiom for last and create, last using create, and that is exactly similar to this axiom that we have written, and in that particular case the value that we will get back is the last index, that is L. So we write this axiom and we get the value L there. So we have this last, create, two parameters to create, the first index and the last index, and what we should get back is the value L. So this pair is very, very simple. Now let us look at a slightly more involved example, and that is, let us write the eval function for this create. So eval takes two parameters. Remember, eval has two parameter, array and the index, integer. So we need to give it two parameters. The first one is array, so we make an array through this create function, and then we need to give it an index, let's say I. Now the question is, what is the value stored at index I when this array has just been created? Now this is a very interesting question, and it all depends upon what is meant by create. अगर आपका मेथड ये इस तरीके से लिखा हुआ है कि create, when you create an array, all the elements are initialized to some value, then the value present at that index would be that initial value that you have. And if this data type that you have just created, for example, you have created an array in C++. So आपने एक array create की C++ में, let's say, which has indices from 0 to 9. So if I ask you this question, you have just created the array, you have not assigned a value at any index. So it is just a new array, no value has been put in this array. So array is from 0 to 9, the indices are from 0 to 9. So I ask you this question, okay, tell me what is the value at index number 5. So what is the answer? The answer in that particular case is, it is garbage. I don't know. No value has been assigned. So it is a meaningless value. Whatever you get, will be meaningless, since the elements, they are not initialized. So it is garbage. So one way of saying this thing is garbage. The other way is, we say, when there is no value assigned at that particular index, we say that value is undefined. So when the array has just been created and we want to find out what is the value at a given index I, the answer in that particular case is undefined. And note one thing here, that when we were defining the specification, we said undefined was one of the elements. So the element could have this value undefined. So this is where we use that value. So we have written axioms for the three inspectors in terms of the first constructor create. Now let us write these axioms for the second constructor, that is assign. So once again, what we are going to do is we are going to write, take these three, that is first, last, and eval, and now we will use this assign as the parameter, as the method through which we get this array. So we get this first, and the parameter is assign. Assign takes three parameters. The first one is the array A. So now we are talking about these parameters. So first one is an array. The second one is the index onto which we are storing the value I, and third one is the value V that we store there. So the three parameters, the array A, the index I, and the value V that we need to store there. Now the question is, this is a modified array. So a modified array, it could be a new array, it could be, we are not going to talk about the implementation details. Does it, change a value inside this array, or does it create a new array and give you a new array, whatever. In most cases, it does not create a new array, but it may, in certain cases, in certain languages. But as far as we are concerned, this is just an abstract entity. This is, as far as we are concerned, it has just modified an array and has given us probably a new array. Now the question is, what is the first index of this array? Very interesting question, and you need to think about it. Now we started with this array A. Let us assume that it had the first index 1 and the last index 10. And we assigned, or we put this some value V at index 5. And we get this new array, or updated or a modified array. So what is the first index of this new updated array? The first index is the same as the first index of the input array, isn't it? We are not going to change the first index. And this is what we are going to write here. So this is first of So the specification here is saying that by assigning a value or putting a value at some index in an array, we are not changing the basic structure of the array. The first index of the array stays the same, and so will be the last index, and we will write that, just like this. So these axioms, they are telling us that we actually do not change the basic structure by putting an element at an index, the array size remains the same. The index, first index, is the same as the old first index, and the last index is the same as the old last index. We are not yet talking about what happens to the values which have been stored inside the array, but we are just saying the first and the last, they stay the same. And this is a precise definition. So we say that when we assign a value, the first and last, they do not change. So this is what we are specifying here. Now we have to write this eval in terms of assign. So this is once again an interesting operation. So we have eval, we have assign a I v, and we say, okay, give me the value at index number j after I have assigned a value at index number I. Now, once again, an interesting question. What happens if I happens to be the same index for which I want to get this answer? That means, the value that I will get is v, because this is the value that I have just put there. So if j happens to be that index where I have just put the value, I will get that value back. Otherwise, what will happen? So we write, if I is equal to j, then the value that we get back is v. Otherwise, else, the value that we are going to get is the old value that was stored at index j in that array that was passed as parameter. So what we are saying here is that except for that particular index I where we have put the value, we do not change any other value. जरा थोड़ा सा unconventional तरीका है सोचने का. So what we write is, we will say, we will get that value that has been stored there before we actually added or put this new value. So how do we write that? We simply say eval a j. So this eval aj means this a is the same as this old array that has been passed to this assign. So before this assignment, whatever that array was, whatever the value present at this jth index, it is the same value in case this I and j, they are not the same. So what we are saying here is, we are saying that in this particular case, we only change value at one point, and and if we query for the value present at that point, we will get the value that we have just put there. The rest of the values, they do not change. They will stay what they were before this assignment operation. So here we saw how could we write axioms for our inspectors in terms of the constructors. ये एग्जाम्पल गो के बहुत एब्स्ट्रैक्ट किस्म की एग्जाम्पल है, एंड टिपिकली क्योंकि एरेज हमेशा हर जगह पे अवेलेबल होती हैं तो हम उसके बारे में इस तरीके से सोचते नहीं हैं. बट हियर you see that we have given a very precise definition, specification of these different functions. We say कि अच्छा हम इसमें कोई चेंज करेंगे, तो जब हम चेंज करेंगे, जब उसकी स्टेट चेंज होगी, तो उसके बाद what do we expect? We expect we can get the answers through the inspectors. So we can get these values through the inspectors. That is the only way that we get the values back. So we say we change the object, we change the type that we are defining or an instance of that, and once we do that, what happens? And this is what we are defining. So in the case of the first three inspectors, the three inspectors that we have, the assignment का constructor use करते वक्त हमने तीन चीजें कही. हमने कहा the first index does not change when we assign, the last index does not change when we assign, and once we assign something at that index, and if we make that query, we say, okay, give me the value at index j. We say, okay, if that index j was the one where we had just put the value, then we will get the value back. अगर हमने फिफ्थ इंडेक्स था, i की वैल्यू 5 थी और j की वैल्यू 5 थी और हमने वहां पर वैल्यू 10 वहां पर रखी थी, we will get the value 10 back. But if I was 5 and j was 7, that means we are saying in that particular case the value at j will be the same as the value before this operation. तो इसका क्या मतलब है? इसका मतलब यह है कि हमने सिर्फ ith लोकेशन पे हमने वैल्यू चेंज की है. And we have given a very precise specification of what happens when we create and what happens when we assign. When we create, that means the elements are all undefined. There is nothing that we can use properly. We should not be using. और अगर ये मेरी स्पेसिफिकेशन इस तरीके से होती कि मैं वहां पर वैल्यू 0 पुट करता, फॉर एग्जांपल कोई मेरी ऐसी लैंग्वेज है जो उसको इनिशियलाइज करती है टू सम इनिशियल वैल्यू, इन दैट पर्टिकुलर केस आई वुड हैव पुट दैट वैल्यू कि ठीक है, आपने यहाँ पर कोई नई वैल्यू असाइन नहीं की, तो जब आप इंस्पेक्ट करते हैं, जब आप व्हेन यू लुक एट दैट वैल्यू, you will get this initial value in this particular case. And if it is garbage, in that particular case, we are saying it is undefined, it is not defined. So very precisely we have specified what we do and what are the expected results. और वो expected results आपको inspector की form में आपको वापस मिलेंगे. So ये algebraic specification के बारे में ये एक introductory सा आज हमारा lecture था. Algebraic specification, once again, just to recap, we use algebraic specification to specify the behavior of abstract data type, in abstract terms. So what happens is, we have in the notation that we are using, there are 5 components in the structure. The first 2 are the introduction. The third one is an informal specification of the functions that are supported by that type or sort that we are defining. And the fourth one that we have gives us the signature. That is, these are the methods, these are the functions supported. It takes these as the input, so types of the inputs, and it gives also the output that, this is what we get. And the 5th component here is our axioms. And we write the axioms in terms of, for inspectors, in terms of the constructors. Algebraic specification पे हमारी गुफ्तगू जारी रहेगी इंशाल्लाह. अगले लेक्चर में I will continue from here. उस वक्त तक आप मुझे इजाज़त दीजिए. खुदा हाफिज़ और अस्सलाम वालेकुम.